Okay, so we've been talking about factoring the last 2 days here now. So the reason you factor these guys is so that you can use that zero property, where if you have all these factors, if your equation was essentially originally equal to 0, then you can set all these factors that you found, each of them equal to 0, and solve for your variable. So we're going to do the same thing and factor number 13, 14, and 15 on this back page. But after we factor them, you have to take it a step further and actually solve for your variable. So let's look at number 11, or I'm sorry, number 13. And it gives us 3x to the 5th plus 15x equals 18x cubed. Now remember what I just said, guys. If we're trying to use the zero product property, or the zero property, then we need to get our equation equal to 0. So right now it's not equal to 0. It's equal to 18x cubed. We have to move that over. So if it's positive 18x cubed, go ahead and subtract that over to your other side. Now, if there's no x cubes to subtract it from, don't try to subtract it from the 3 or the 15. It just has to go and get squeezed in over there. And I'm going to put it in the middle since cubed is between a power of 5 and a power of 1. Now our equation equals 0. So we have to factor this like we've been doing today and yesterday, and then set those factors equal to 0. So can we pull out a common term first? You may not always be able to. That's just always the thing you want to check for first. So 3, 8, and 15, biggest number you can pull out is a 3. Between x to the 5th, x cubed, and x to the 1st, the most you can pull out is 1x. So now we're left with x to the 4th minus 6 x squared plus 5. And again, that x to the 4th, guys, that's fine. All that's going to happen here is that you're going to have x squared and x squared instead of an x and an x. We still need to know what multiplies to get us 5 and adds to get us -6. So we'll have x squared and x squared. So what does multiply to get you 5 but add to get you -6, -5, and -1? Okay. I'm looking at this. Can we take it any further? X squared minus 5. X squared is a perfect square, but 5 is not. So that one's done. But x squared minus 1, we can take that one step further and say that's a difference of squares. So the square root of x squared is 1, or 1x, and the square root of 1 is 1. So x plus 1 and x minus 1 equals 0. So the last thing we have to do is set each of these factors equal to 0. And the factors aren't just the things in the parentheses, guys. Remember, factors are everything being multiplied together. So technically, your 3x on the outside here is also a factor. So each individual factor equal to 0. And then we have to solve. So here, all we're going to do is divide by 3 and get x equals 0. Here, we're going to add 5 and get x squared equals positive 5 to undo that squared power to get just x. We're not trying to solve for x squared. We're trying to solve for x. We need to undo that power of 2. So by taking the square root, that will give us just x. We can't really break down the square root of 5, so it just stays plus or minus, positive or negative, whatever the value of square root 5 is. Here, if we add 1, we get x equals positive 1. And here, if we subtract, we get x equals negative 1. So just for this one single equation, guys, we have 0, positive square root 5, negative square root 5, positive 1, and negative 1. That's 5 solutions. And that's good because as we move along here, this exponent, guys, of 5, that's going to tell you how many solutions your equation is going to have. So the fact that we got 1, 2, 3, 4, 5 solutions is a good thing because that matches your degree of your polynomial. Okay. Number 14 is very similar to that one, guys, so I want you to try that one on your own. I'm going to do 14, or I'm going to do 15 with you guys. So go ahead. You can pause it now and try number 14, or watch number 15 and then do it. But I want to do number 15 with you. So number 15 is negative 27 x cubed plus 15x squared equals negative 6x to the 4th. So again, if we're trying to solve this or use the 0 property, our equation has to be equal to 0. It has to be in standard form. So we have to move that 6x to the 4th over, and if it's negative, that means we need to add it over. So it becomes a positive 6x to the 4th minus 27x cubed plus 15x squared. So the most that you guys can do, and it's equal to 0, the most you guys can do is pull out, it looks like a 3 goes into 6, 27, and 15, and we can pull out 2 x's, or x squared. So let's go ahead and do that. So pull out a 3 and x squared. And that leaves us with 2x squared minus 9x plus 5. Alright, so again, we're just factoring, pull out that common term, so 3x squared is going to be a factor, and then we have to break down that 2x squared minus 9x plus 5. But when I'm looking at this, you guys can try all you want, but we can't factor this. So if we can't factor this, and it's a quadratic because it's a power of 2 here, there's always one way that works for every single equation if it's quadratic to solve for x, and that's to use your quadratic formula. So we have to use the quadratic formula to solve for that part of your equation. You guys can solve for 3x squared right away and say, okay, divide by 3, get x squared equals 0, take the square root, and get x equals positive or negative 0. Technically, it's only one solution, but we'll write it as positive and negative. So let's find our other two solutions by using the quadratic formula. So a is going to be 2, b is going to be negative 9, and c is going to be 5. So plug this in. So negative 9
plus or minus the square root of negative 9 squared minus 4 times a, which is 2, times c, which is 5, over 2 times a, which is 2. So we get 9 plus or minus 81 minus 40 over 4. And I'm just taking it one step at a time here. So then 81 minus 40 is going to give us 41 over 4. Okay, you guys can try all you want to break down this 41, but you can't. So that would be your next step to see if you can break down what's underneath that square root. And it's not negative, so I don't have to bring out an I. So my other two solutions are going to be 9 plus the square root of 41 over 4, and 9 minus the square root of 41 over 4. So it looks like we came up with 4 solutions, which is good because we had a power of 4 that was the degree of our polynomial. Technically 0 and it counts as 1, but if you count it as a positive and negative 0, it would give you 2 solutions. And then your 2 solutions you got from the quadratic formula. So again, guys, if you can't factor, say you were on a test or quiz and it says solve for, if you have a polynomial that's squared, a power of 2, you can always use the quadratic formula to solve it. So go ahead, try number 14, and again, ask if you get stuck. Ask if you just want to check and make sure you're doing it right.